Hey everyone, Abhishek again, and in this video, I'm going to talk about one of the feature I've been thinking about building it for over a year, and I had read a lot of blogs, research papers, so finally thought of building it now because parallelly I've been also working on one of my side project, GStream, and no, it is a similar project, so I thought why not build this project and club it together with GStream and open source it or like sell it maybe. I don't know. So you might have used Shazam or music search in your Android phone. Suppose you are listening to some song and thought like no, you don't remember the name, so you just turn on the mic and it listens to your song and gives you the name. So it is one of the complex project because there are billions of songs right out there. You can't just take one song and search it because the song can be indexed. Like if you have read about database or use it or backend systems, you might be knowing that you just can't go and put a song in a database and search it. So like search it using a clip. So I thought why not build it because I'll get to learn a lot of things about audio engineering and simple database stuff. So finally I was thinking about approach without googling it, and I came to this solution that uh, I can take the song and extract all the text from it and put it into a database, simple MySQL, Postgres, and any SQL database or MongoDB. Put the text and I can search it based on the text. Even if I have a clip, I can take the words from the clip and search it right there. But one of the problem I encountered was, suppose there's this song, girls like you, ting ding ding ding, guys like me, so this ting ding, this music note, I know this is not the song, but you just just think about the music note. You can't convert. Suppose you have a clip of this music note, or suppose there is this guitar tune, and you want to search it in your database, and this guitar tune or the verse like you music note can't be indexed because it has no words. It has only emotions. So how do you search it? So my solution was a dead end for that no, for this problem. So I had to finally Google it and read few blogs. I read one research paper, and now I was confident that I can build it. But still, it required a lot of mathematical knowledge, which I don't have. Barely passed my. Leave it. I'll just not talk about my marks here. Uh, it might have bad approach on my masters if I am doing. Anyway, so I'll just talk about the second approach, which is the solution to this problem. I will just show you right here because I can't tell you or express you, uh, not my feelings, but this approach. So just look into this and see how it works. So instead of going through the research people, I will talk about the Medium article here. This is very precise and like easier to understand thanks to Cycle. You will directly go to the point here. So here it has written we will store the frequency and time for each point of interest POI. Earlier what we were doing is we were storing the words from the songs and we were indexing it and searching on based on the words. But here what we are doing, suppose you have an audio, suppose you have a guitar tune. I know every audio has a frequency and amplitude. So frequency is basically change of amplitude of the audio, right? Correct me if I'm wrong. I'm very weak at audio engineering and all. I mean basics. So here what we are doing is we are storing the frequency and time of each POI. POI here is point of interest. So we are not storing all the songs in the database. We are also not storing all the frequencies. We are only storing the frequencies which has greater steep or crests. I mean, it has some deep depths or heights. we are only storing those. And yeah, size does matter. Anyways, and here, as you can see, we are also not, we are storing the frequencies as a pair of the frequencies along with the time interval. So what we are why we are doing is, suppose we have a song of 50 seconds. Just take an example here. We have a song of 50 seconds, and suppose 60 seconds, and we have two point of interest, one at 20th second and one at 50th second. And someone has a clip which starts at 10 seconds and ends at 50th second. Okay, so uh, the point of interest of this clip will have at 20 at no at the 10th second, and this will have at 40th second, right? So if you store the time, it will be different because the starting and ending time of the clip is different, and this song is different. So no, if you calculate the interval, 50 minus 20 is 30 and 40 minus 10 is 30. So if you have the interval, you can match the points. So that's why we are storing the time interval as well as frequency pairs. I'll just show you something. So here I have uploaded this audio, Girls Like You, and we have calculated the fast Fourier transform of the this song. On the left, on the x-axis we have amplitude. Sorry, we have on the y-axis we have amplitude. On the x we have frequency, and you can see the crests and the depths we can see. And so in this audio, we can take this point, this frequency, now all the depths or all the crests. I don't know what to say it. So you can take all the important points here and store into the database. And suppose you have a clip of this part, then you can find it in the database. So like easier to understand would be this. I'll just show you. I might have copyright strike. I'll just slow down the volume. So you can see we can store these values, not all these. No, we can also store these kind of frequencies, where we have major ups and downs. So just wanted to show you this, and so the things has mostly built. I will push it to GitHub when everything is built. So let's wait for it and see how it works. And thanks for watching this video, and bye bye folks. Let's meet in this next video.